All right. So question 2. All right, so our goal is to make this LL1 parcel. So we scan here a little bit and we see S goes to M and M goes to A, and we see that's going to be a conflict. So what most of you did, and it's probably the easiest, we write S goes to A or B or MB or AB. And then M goes to paren B paren, and B goes to SBA or SF. So apparently there's a class up there at noon that's got to rearrange all the tables until they get settled down. All right, so we need to keep the original MB for this, since we didn't substitute it in. And then the OR A, we did substitute in for the M, so we get it up here, allowing us now to left factor it. And so we get S goes to B or MB or XB, and X goes to A or empty. And so that's not right. So what am I doing wrong?
B or empty.
That's not right. I think that's not right.
All right, I claim to.
See how good this eraser is?
Oh, you got it.
Compliments of
The chef.
Abu Bakr. And he wouldn't even let me pay him for it.
Oh.
And it reaffirms that Amazon has everything. They do have everything. That's so cool. Now I'm stressed though, for I have to carry this eraser with me wherever I go forever, and I can't forget it, for then I'll be depressed.
Solution. You tie a chain to it to your belt, so it's like dangles. You know, like for the wallet. Yeah.
And keys.
Yeah.
Yeah, that'd be so cool, and it would look great bouncing off these black pads.
Fashionable.
All right, so what do I need? I need some. So S goes to XB, that's what I wrote. Or B, or MB. And X goes to, why can't I write this?
It's AS, not XB. S goes to AX.
And X goes to B or empty.
There you go.
Okay. Yeah.
Who wants to teach this class? Somebody else? Cameron?
Yeah.
Take over.
Okay, cool.
And so M goes to paren B paren, and B goes to S Y, and Y goes to D A or F. So then, so we think we might have it. And so then we do the first of AX intersect the first of B intersect the first of MB. A, B, first of M is going to be left paren. So then we do the first of B intersect the follow of X. Well, now we got trouble, huh? So, first of S, X, M, B, and Y, A, B, and left paren, B and empty, left paren, A, B, and left paren, D and F, follow S, X, M, B, and Y. So B is in the follow of M. Right paren is in the follow of B. The first of Y is in the follow of S. So the first of Y is D and F in the follow of S. The follow of S is in the follow of X. The follow of B is in the follow of Y. Can Y generate empty? No. So now the follow of X is $D and F. The first of B is B. They have nothing in common. No choices here, no choices here, choices here. So we need the first of D, the first of DA intersect the first of F, D, F. So they have nothing in common. So the grammar is LL1 parsable now, and we fixed it. So now I promised you an additional example on Thursday, and so let's do this. And so we have S, X, M, B, and Y. And we have A, B, paren, D, dollar, F. So I've got all of my terminals. So S goes to AX on the first of AX. So I write an AX in here. S goes to the first of B. S goes to B on the first of B. So I write a B in here. S goes to MB on the first of M, left paren. So I write an MB X goes to B on the first of B, so I write a B. X goes to empty on the follow of X, dollar D and F. So it goes to empty, empty, empty. M goes to paren B paren on the first of paren B paren. B goes to SY on the first of S. So SY on the first of S. SY, SY. Y goes to DA on the first of D. And Y goes to F on the first of F. So I built my table that guides my parser. Yes? It's going to be a good image of that button. Make sense? Questions? Zach? Where's Zach? There's a Zach back here someplace. Questions? There he is. Zach?
Yeah.
Good? Randy? Randy? I'm learning new names. All right, so now we can parse. So what does this generate? S generates an MB, S generates an MB, so it generates paren B paren, B generates SY, S generates B, Y generates F. I claim maybe paren B F paren. A haphazard derivation. I don't care if it's right or not, because when I parse it, it's going to tell me whether I did the generation right. So paren BF. So paren BF paren, followed by a dollar sign, and S followed by a dollar sign. S is my start symbol. So this is now easy, because I just do as I'm told. So I have S left paren, and so that says, see, I'm looking at this token, right? So paren B F paren dollar, and it says left paren, put on MB dollar, pop the S and put on MB. Now you have to be a little bit careful. In a couple of weeks, we're going to do stuff that's going to look almost the same, and I'm going to write the stack different. I write my operations on the right, and I replace the S by its right-hand side. By writing the stack over here, it puts the leftmost symbol of the rule on the top of the stack. That's not done by accident, because I'm always replacing the leftmost symbol, so I want it to appear on the top of the stack. So on test 2, you've got to do this as well as the other one, and we write the other one backwards, sort of, so you got to keep them straight. Just put a footnote to write this in this pattern. All right, so M left paren says put on paren B F paren dollar, paren B dollar. I pop the M, so then the tokens match. I've got B F paren dollar, and I've got B paren B dollar. I look up BB, and it says put on SY, BF paren dollar, SY paren B dollar. I look up SB, and it says put on B, so I have BF paren dollar, BY paren B dollar. The B's match, I have F paren dollar, I have Y paren B dollar. I look up YF, and it says put on an F, so I have F paren dollar, F paren B dollar. The F's match, paren dollar, paren B dollar. The parens match, I have dollar, B, dollar, and I don't know what to do with that B, so I say fail. It didn't parse. I must have screwed up my derivation after all. Kevin?
The table doesn't look.
Table doesn't look right?
Yeah,
Ouch.
under Y. It looks like the DA should be in the column in the cell just to the right of it. Y, right, paren. The DA. Should that be under D? Yeah.
And 38 people sat here and watched me do that and didn't say anything? You wanted to see what was gonna happen, didn't you? So let's back this up a little bit. Let's back it up to here just for grins. I'm so happy. Look how good that eraser worked. It was worth the $50 you spent for it. SB. Why I never did that, I have no idea. I just never remembered to do it. So the B's match. So
I claim that you can't make that with the grammar rules.
that's what happens on a Monday, right? And so Y says replace F paren dollar, F paren B dollar. Match the F's, paren dollar, paren B. Match the parens, dollar, B dollar. Now Kevin was right, I still had that in the wrong column, but it didn't help.
Yeah.
Questions? Make sense? Sonia?
How did you pick your input strings?
I picked my input string because I wrote this down.
Why did you write that down?
I wrote that down because I looked at the grammar and I said, well, it goes to M, MB. And so I should have had a B on the end of it to start with.
Yeah.
I wasn't careful in generating a test string.
It's okay.
So I looked at the grammar and I said, well, I get an M, so I wrote that and I forgot about that B. And then B went to S. Well, I'm doing this one. So MB, B goes to SY, so I wrote the SY in there correctly. And S goes to B, I wrote that in correctly. Y goes to F, that's correct. So I think that should have parsed. What did I write over there?
You're missing the B before the dollar sign on your input.
Yeah, so had I written correctly the B that belongs here, everything would have parsed. It would have matched up when I was at the end. So I just didn't capture my B when I generated it. That's still cool, because an example of it not working is informative. They don't always work. Every program you ever written parsed the first time? Not a semicolon error or anything ever? You're a lot better than me, because every one I write fails the first time. Good? Questions? All right.
Yeah, I've got questions about this. So, the stack goes left to right, and then the input string is the same way, so you're just matching left to right.
So what?
The stack is left to right, and the input string is left to right, so you just have your, it's set up that way, so you just have to put it,
What I was talking about with the stack and the left and the right stuff is when I'm replacing a non-terminal by its right-hand side, I want it so that the M, the leftmost symbol, is on the top of the stack rather than them being reversed. And so you can draw this stuff however you like. And by that I mean I could draw it so that I had paren B, F, paren dollar as input. That makes some sense because I'm looking at the current token. And then I could write dollar S, and that makes some sense because now this is the top of the stack, and the top of the stack is close to the input character, and that's aesthetically pleasing. We feel good about it. But then, when I look and I say S left paren MB, I've got to write dollar B M paren B F paren dollar. And so I actually reverse this because I got to have the M on the top of the stack because I'm doing a leftmost derivation. And so this is top, and this is input, if you like. At least I'm looking at the leftmost character here. So, I don't know, half the time when I teach this, I do it this way, and then students have to remember to reverse this. Or I do it that way if I think it might be easier for you. And you don't have to reverse it, but at the same time, you gotta look clear over here for the input token. Yeah, trade-off. Everything in the world's a trade-off. Brandon?
Can you finish that, actually?
Well, that's this.
Yeah.
I'm gonna get to exactly the same place. It's just I'm writing it in reverse order. I mean, I got M on the top of the stack and B next. I've got M on top of the stack and B next. My stack looks like this. My stacks lay down in here. In data structures, I assume your stack's set like that. My stack lay down in here. Make sense? Good?
I was just wondering if that's what you were saying. Yeah, that's the way it goes in the book, but it's easier this way because, like you said, you don't have to reverse it.
Yes.
Also, just want to verify something I noticed. The lexical analyzer looks at one token, looks at a symbol, and then and it also looks at the next symbol. Well,
It's always looking at the next symbol, or if you like, the current symbol. This is the current token.
No, I meant that,
And it keeps looking at this current token until it matches or consumes it. Then it immediately gets to the next token.
I know that, I'm comparing the lexical analyzer to the parser is what I'm saying. Because the lexical analyzer looks at the.
I thought I was saying the same thing you were saying.
Okay.
The parser is the master, so to speak.
Yeah,
The parser is doing the work matching the input to the grammar. And when it matches the current token, it immediately asks the lexical analyzer for the next token. So it always has a token to look at to guide its actions.
okay. Okay, I had just noticed that, that with the lexical analyzer that I made, it has the current token, and then it also looks at it has the current symbol, and it also looks at the next one to try to figure out where it's going. But the parser.
The parser, well, we understand the lexical analyzer. Yeah, the lexical analyzer just creates tokens.
Yeah,
Okay, so it does its job and it quits,
yeah,
more or less. So then the parser has the current non-terminal or the terminal, the current non-terminal or the current terminal that it's matching against the current token.
yeah,
And the current token is provided to us by the lexical analyzer. And so the lexical analyzer is getting us, in essence, one token at a time. And so S looks at the current token, checks out the table, does what it's told, S is replaced by MB. M looks at the current token, checks in the table to know what it's supposed to do. The table tells it to replace M by paren B paren. The parens then match. We accept this token in essence. So now we have B, so B looks at B. That's its operation.
okay. I understand that. I was actually comparing how they look at their respective inputs. How the lexical analyzer looks at this input string and the parser looks at the tokens. Because the lexical analyzer, what I was saying was that it can see one character on the input string and it can also see the next one. So it actually sees two at a time. But the parser works differently because it's still considered to have one look ahead, I think, at least that's how they say it. But it can only see the one token, which is why we need the first and follow sets like that.
Kevin's just trying to make the point that the lexical analyzer can look at current position and next position, but the parser really can only either look at current token and the first follow sets. It's not really a question, it's more of a statement.
Well,
I'm just making sure that I understand.
so the lexical, so we're looking at things like this. So the lexical analyzer checks this out and identifies a keyword. That's what the lexical analyzer does. Well, this then becomes one item, like a left paren. That's a token. That's a complete entity. Then it checks this out. Then it checks this out. This becomes, I'm not saying anything about this because this is one item. This becomes one item. It's an identifier. It's like a B. And so in our parsing examples, each one of these things constitutes a token, like this is a token, 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 this is a token. And so the lexical analyzer makes each of these look as though they're one of these. So we're doing parsing examples with single character tokens for simplicity, which are what's returned by the lexical analyzer.
Yes.
This is a single item, a single token, the two characters together. And so the lexical analyzer groups the input into single items. And our parser then is looking at the single items one at a time returned by the lexical analyzer.
Yeah, what I'm saying is the lexical analyzer, when it starts looking at the input string, it starts on the I, and it can see that it's on the I, but then it also looks at the next thing, it looks at the F. So
Yeah, in order to make a single item.
yes, that's what I'm saying. It looks at the, and it's always looking at the one that it's, the character it's on, and the next character.
Well, it's building a token. And so it's got to capture the group of symbols that constitute that token.
I see. It's because it works with multiple symbols that it has to be able to look at what it's on and the next.
Well, it looks at what it's got and what it's getting, so to speak, in order to build the token.
Exactly. I'm saying that that's. Meanwhile, the parser has tokens that, like you said, that are separate, and it can only look at one of those at a time.
But it's looking at a token that represents multiple symbols, potentially.
I know that. I'm saying that if you consider the characters, the units that the lexical analyzer looks at, and meanwhile the tokens are the units for the parser. Each of them looks at one of their two or one of their respective units. The lexical analyzer looks at two, and the parser looks at one. It's because something I noticed.
So we might think about, for example, we might think if parenthesis XXXX is our input string, that we then want to parse.
I don't. Oh.
I feel like we're saying the same thing over and over and over, and
I don't. I'm.
are you confused?
Yeah. It's.
You are?
I guess it's kind of abstract. I'm just trying to get this.
What
I'm considering the amount of look ahead that each thing that each process, each algorithm has.
So I don't know how to say this any better. And I've never really, maybe students have been confused by this in the past, but I've never really had this question. We've got, say it again, we've got the lexical analyzer.
Yeah.
It groups symbols together in such a way that they become, in essence, one item.
Yes.
Okay? That one item then is then passed to the parser.
Yeah.
The parser looks at that one item to decide what to do. It doesn't look at the individual characters because the lexical analyzer already has made those individual characters into one. So it doesn't look at an I and an F, it looks at a token, in essence, a keyword. You say, yeah, but then you ask the question.
Well, he's not really asking a question, he's just making a statement.
Well,
Just trying.
so I agree with the statement, I guess. I mean, I don't know. The lexical analyzer groups multiple characters into a single token, which the parser looks at then as a single entity. The lexical analyzer groups multiple characters together. The parser typically looks at one token at a time to decide what to do. See, we're doing an LL1 parser. The LL implies top down, and the 1 implies 1 token look ahead, or 1 token, we're looking at this token that guides the function of the parser.
Exactly.
We can write LL2, in which case the parser looks at this token and this token, and between the 2 of them, it figures out what to do. There exists LL2 parsers.
Yeah.
But the lexical analyzer is in this box all by itself, and it's just putting out tokens, which the parser then looks at those tokens 1 at a time, in our example, 1 at a time, to do what it's supposed to do.
I think he was just comparing the way the lexical analyzer looks ahead to the way the parser looks ahead.
Exactly. Because-
I would claim that the parser and the lexical analyzer look ahead exactly the same amount. They're looking at the next, in the lexical analyzer's case, it's looking at the next character. In the parser's case, it's looking at the next token. And both of them guide what it does. It looks at X, it looks at X, the next X, it looks at the next X, it looks at the next whatever, blank, and it says, whoa, I got an identifier. An identifier is a thing. The parser then will ultimately look at that identifier
Okay.
and do its thing.
Okay, I think I may have been thinking about it wrong because.
I think you're making it a lot harder than it is.
Okay, so the parser looks at 1 token and the lexical analyzer,
Looks at 1 character.
I guess it doesn't have, I guess you can't really say that it's looking at 2 at a time because it can actually tell. Because if it's on a character, then it also knows where it was in terms of making another token. So all it really needs is the next one because it already took in the input from the last character.
Well, it's constructing its token, that's true.
Yeah.
And so it's remembering what it has,
Okay, so I guess you could.
but it's only looking at 1 character. So as I walked out of my office, I had a student follow me out who was distracting me on system software. And so I forgot your exam, which I was going to read to you on what's on the exam.
I'll go get it.
That's okay?
No, I'll get it.
What's going to be example?
So you don't care what's on the exam?
No, I'm saying I will go get it.
So I'm going to walk up and get the exam,
Yes.
and I'll be back in 5 minutes.
Yes.
Come on, Professor Cameron, take over. What are you gonna do? We're gonna go over number 3, is that okay?
When did you give this to
What's a big
present relationships between this is a thing, this is a I did, and anything that has to sorry, I just need to go loop because I can very separated.
Cameron. Yes, sir. I'll post this on YouTube too, okay? Okay, let's do it. You better do it right.
This is representation. It's up to you. It's multiple you do. So it's.
All right.
When you get it, yeah, people especially.
Tell them.
So you need to do the first of X. Excuse me. Back. All right. So the first set's pretty easy. Hello. Yes. So the first set's pretty easy. We're going to start with the ones that are the most simple. So whether that would be X and Y.
Is this on the test?
Possibly. Most definitely be on the test.
Yes, it will be.
Professor?
Yeah. Does anyone disagree with this so far? First of X is D or an empty. First of Y is F or empty. So let's move on to the first of, I forgot to write B on here. We're out of time.
Some other time. Yeah, 2 o'clock.
No, what'd you stop?
I made a bad mistake.
What happened?
I went into the Jeep dealer right down the road.
Okay.
Now they're calling me all the time.
Oh,
Yeah, I was thinking about this when I was walking up there. We gotta do this.
I have a disagreement, but yeah.
You have a disagreement?
Yeah, for what I got marked off on my test versus what.
Well, so there's about a half a dozen of you who are upset with me.
yes, when you do the first set, please.
And that's because you modified the grammar and then did the first and follow. The question says, find the first and follow of this grammar. Doesn't say find the first and follow of some other grammar that you changed to. Now, if you convince me that your first and follow of the grammar you did is right, I'll give you credit, but at this point I marked it wrong. So you got this whole grammar. S, Z, S, A, B, A, X, Y, B, A, P, G. Yes, this is, I'm glad you did this. This was a good thing to do while I was gone. B, A, P, B, empty. B's rule went down the bottom.
Yeah, I forgot it when I wrote it down, so.
Yeah, okay. D, A, F, D, F, B, and go. All right. All right. So we have to do this carefully. So X is D and empty, yes, they were easy. Y is F and empty, yes. All right. So the first of A is B and empty, and then the first of B, which we don't know yet. So the first of B has got a whatever that thing is, a G?
Yes.
And so the first of B is G. The first of B is G, and the first of B is the first of B, which has got to be G. It can't do anything else. And so the first of A is the first of B, who is G. B and empty. Doesn't go away, so that's all that A can be. The first of S is the first of A. A can go away, so the first of S is the first of S, B and G. This first of S can't go away, because it's B and G, at least at this point. The first of S is the first of B. The first of B is G. The first of S is the first of X, who is D and empty. the first, since X is empty, the first of S is Y, who is F and empty. So since X and Y can both go away, so can S. The first of S prime is the first of S. The first of S can go away, so it's the first of Z. The first of Z is the first of A. The first of Z is the first of A, who is B and G. A can go away, so it's M. So it's just M. So the first of S is the first of S and the first of Z, who is B and G and M. And no empty because the Z can't go away. And so,
Wait, why did you put an epsilon in the S prime?
I'm sorry?
Why isn't there an epsilon if S prime is first?
These both can't go away.
But isn't,
S can go away, but Z is going to generate a character other than empty.
but isn't there an epsilon in S? S is first?
There's an epsilon in S, so S can go away, yes. But S prime generates what this generates. S can generate a B and a G and a D and an F, and it can go away. If it goes away, then S prime generates what Z generates. Z generates a B and a G and an M, but not an empty. S prime itself cannot generate an empty. It must generate a character. Okay? Adrian.
Can you explain again how you got the epsilon and A, please?
The epsilon and who?
A, letter A, yes, sir.
There's an epsilon right there.
Oh, how about the S?
So X can go away. Y can go away. So S can go away. So sorry.
Do you look in both X and Y or just X when we do the first?
We're looking at what S can generate, right? Okay? Okay, follows. Man, see how fast I erased that? Erased that, made up for the time I walked up to the office. Believe that? All right. The first of Z is in the follow of S. The first of Z is in the follow of S. B, G, and M in the follow of S. The first of A is in the follow of S. B and G. I only had one stroke in grading these. One of you put an empty in follow sets. It was a big one. Remember you're probably too young. Remember, what was it? Where Fred, oh gosh. He ran a junkyard. And he was an older fellow. What was it? God, I shouldn't have started this story. It's poor, I can't remember. Anyway, he kept saying, "This is the big one." The guy, as though he was having a heart attack. It was pretty funny. Sanford and Son, that was the name of the show. Sanford and Son. And Sanford was a fellow who ran a junkyard who kept having heart attacks, except he never did have a heart attack. So now I don't know where I was. The first of A is in the follow of S. I did that. Can S generate empty? Yes, it can. So the first of A is in the follow of A. The first of A is in the follow of A. All right, whoop-de-doo. The first of S is in the follow of A. The first of S, B, G, D, F. B, G, D, F. In the follow of A. The first of little a is in the follow of B. The first of Y is in the follow of X. The first of P is in the follow of A. The first of A is in the follow of B. Can A go away? Can A generate empty? Yes. So the first of P is in the follow of B. The first of M is in the follow of A. The first of, what is this, Q?
Yes.
The first of Q is in the follow of V. Okay, the follow of S is in the follow of Z. The follow of S prime is in the follow of Z. Can Z go away? No, it can't. The follow of S is in the follow of A. The follow of S is in the follow of A. Can A go away? Yes, it can. The follow of S is in the follow of S. Whoop-de-doo. The follow of S is in the follow of Y. Can Y go away? Yes. So the follow of S is in the follow of X. The follow of B is in the follow of Z. Follow of B is in the follow of Z. The follow of B is in the follow of A. Okay, iterate. The follow of S prime is in the follow of Z. Z can't go away. The follow of S is in the follow of A. The follow of S is in the follow of Y. Y can go away. The follow of S is in the follow of X. The follow of B is in the follow of A. The follow of B is in the follow of Z. I think we have it. Questions? On the, well, we got lots of time. Where's my phone phone? Good. On the exam, number 0. I didn't really do that, did I? No. Yes, I did. Question 0. Eliminate the left recursion. Question 1, eliminate the left recursion.
Question 1 or question 0? I'm sorry.
So what's the difference between 0 and 1? They're both eliminate the left recursion.
Same question.
Different grammars, of course. Same question. The question 1 has indirect left recursion. Question 0 has only direct left recursion. Good? Question 2. Simplify the following grammar. I'll talk to Dr. Elfiuni and say, what's wrong with this university that one of my students has to buy me an eraser? So you learned in computability and automata that a grammar is a for tuple. It has non-terminals, it has terminals, it has S, who is an element of the non-terminals, and it has rules, which are non-terminals go to non-terminals union terminals in 0 or more ways. So that's the definition of a grammar. So it's got a set of non-terminals, A, B, S. It's got a set of terminals, little a, little b. It's got a non-terminal who is the start symbol. And then it's got rules where non-terminals go to terminals and non-terminals in some fashion. Okay? If I write a rule like this, or a grammar like this, that's a different grammar than if I write these two grammars generate the same terminal string. This one is a regular grammar. This one is a context-free grammar. What's the difference? Well, the second grammar has A goes to empty, but I can do it goes to empty in the first one, so that's not it.
One's deterministic, one's non-deterministic.
They're both deterministic. Brandon?
A regular grammar is a special kind of context-free grammar where you've got everything is either in the form of a variable goes to a terminal or a variable goes to a terminal or variable, something like that. It's in a
Something like that.
Special restricted form that the one on the right is not in.
Exactly. He's pretty well got it. This is a restricted form which says all the terminals come before any non-terminal. Here I've got non-terminals intermixed with, here I've got terminals intermixed with non-terminals. So if I write a rule like S goes to A, B, B, C, that's context free. I've got a bunch of stuff intermixed, so to speak. If I write a rule like this, where the stuff isn't intermixed, then it's regular. So this I can represent with a finite state machine. This I cannot. I can do this with a push down automata, but I can't with a finite state machine.
For the regular grammar, does it matter if all the terminals are after the non-terminals or before, or?
It actually doesn't matter, except on the exam I give you a definition of a regular grammar. So for me on the exam, it matters. All right, so on the exam I say, give me a regular grammar that does, and I give you an example of some strings. So you got to make up a regular grammar. If, for example, and I don't know, I'd have to walk back over there and look, but let's say I'm generating balanced parentheses. Let's say, could I do that? I can't generate balanced parentheses with a regular grammar. I take that back. Let's suppose I'm generating A, C star, B. So I'm generating, it starts with an A, it ends with a B, and it's got a pot full of C's maybe in between. So I can write a regular grammar. S goes to A, C, B. And you immediately yell at me and say, no, you can't. If you put the B in the end, it's a context-free grammar. Minus 18 on this 6-point question. You with me? So I can write A, C, and then I can write C goes to C, C, or B. I claim I have now written a regular grammar that generates what this regular expression generates. Yes? This is my start symbol. I'm guaranteed to have an A in the beginning, a C, a pot full of C's, maybe 0 of them, and it ends up with a B. So this is regular. If I were doing balanced parentheses, how might balanced parentheses look? Well, balanced parentheses look like this, yes? That sort of captures. So I might do, I claim that generates all of these guys. And I claim this will generate that one. So I claim that that grammar might generate balanced parentheses. Regular or context-free? Context-free, because it's got a bunch of terminals and non-terminals intermixed. So this is context-free. That one's regular. Four rules for a grammar. This is the general definition of a grammar. I'm impressed with everything is the same except just how you form these rules that distinguishes between regular grammars and context-free. That's a huge difference. Regular grammars don't do much for us. They're a lexical analyzer. Context-free grammars represent very nearly all of our programming languages. That's a huge difference. Just because of a little form of the rule. Impressive. I get goosebumps. Satori?
So how are we going to use this grammar on the test? So you're going to give us the rule, right? And then
I'm going to give you an example. I might give you something like this. And I'm going to ask you to write part of what I've been tempted. I've taught this class 45 times. I've been tempted. Here's the nature of what I want to write. Go off and write a grammar that represents what I want to write. Then build the parser, and so on. And so an additional component of this class could easily be construct a grammar. You're upset and working your tail off now when the grammar's given to you. And so it doesn't have to be given to you. Carnegie and Ritchie started off, wrote the grammar, wrote the parser. They're the guys that wrote C. I don't know who wrote Java, and I don't want to learn because I don't like them. Larry Wu wrote Perl. He started off at scratch. Brandon?
If you were to change this class to have this,
I probably never do change it. I have in the past used a different grammar from another book and stuff. I was tempted to do that this time.
if we have to design our grammar, we would like outline constraints for our grammar.
Yeah, I'd have
So we
to-
can't just make it super simple, like done.
Yeah.
Oh, okay.
We'd have to, I mean, we'd have to try to make it doable. All right, so, question 3 says write a regular grammar that does something. Question 4 says build the LL1 parse table that I just erased and show me a parse. I give you a string.
Wait, Jerry has the.
Is the parse table already there?
No,
Yeah, you build it.
build the table.
Construct the LL1 parsing table and show a parse of using your table for of the following grammar. And show first and follow sets that guide the construction of the parse table. Okay, question 4. Question 5. Question 5 is question 3 on the quiz I just returned you. Except I changed the grammar a little so you can't put it on your 3x5 card that you can bring to the test. Right, you know you can bring a 3x5. You're gonna love this. This just happened last term on the news, national news at me. They did a report on a faculty who says you can bring a 3x5 card to the test. So a student walked in with a 3-foot by 5-foot card. Had everything on it. Made national news. So from then on now, I put 3-inch by 5-inch card to the test. You are welcome to bring a 3x5-inch card to the test. You can write anything on it, front and back. True story. I just heard it last fall. So question 5 is do first and follow of a relatively complex grammar. Question 6 is the following grammar ambiguous? Question 7 is construct a context-free grammar that does something. Question 8 is, given the following grammar, make it LL1. So question 8 is a left recursion and left factoring question. Okay?
What was number 7?
7 is write a context-free grammar that generates examples of what I gave you. Question 9 is make first and follow. Question 10 is a finite automata question. It might be convert the following NFA into a DFA. It might be take the DFA and make it minimal. So that's question 10. You've got 11 questions total on the test since we started out at question 0. Eric?
What was 9? First and follow set?
First and follow sets. Actually, of a simpler grammar than
What was number 6?
simpler grammar than question 8. Or wrong. A simpler grammar than question 5.
Did you used to just tell everyone what was on
You
the
can make
test?
more than one parse tree and make the same tree.
In the past, did you
Then
tell the
just make
students what's on the test?
In the past,
Like this?
Like last semester. when you did the-
last semester, I told them what was on the test. Just like this.
Because when I was like a freshman, I would hear stories about compilers and how scary it was.
Compilers is scary. 25% of you are going to fail.
Oh, the list guy bring this up to things up.
Zach? Not Zach. Robbie?
Can you do an example of creating a context-free grammar?
That's not one over there.
Yeah, that's that.
So,
Suppose I wanted a context-free grammar of characters. This might be too simple, but context-free grammar of A's and B's that are palindromes.
Odd palindrome or even palindrome.
I was gonna say, we're gonna be given the rule, right? And then we have.
I'm going to give you example strings, and you got to make up the rules.
Oh,
So I'm going to say, well, in this case, I described it as palindromes. And so that means AA, BB, ABB, A, BAAAB, BBABAB, man. ABB, strings like that. Right? BABBABBAB, yep. And so build a grammar, I give you these strings, and I ask you to build a context-free grammar that represents that. What's it? Ahmed. I was close. I was getting there.
Are all these questions gonna weigh the same?
No, they don't weigh the same. Some weigh more than others. I burned 1,800 calories yesterday exercising, and I lost 2/10 of a pound. So question, that's the quiz. Where's the test? Question 0's worth 8, question 1's worth 10, question 2 is worth 8, question 3 is worth 5, question 4 is worth 15, question 5 is worth 12, question 6 is worth 8, question 7 is worth 8, question 8 is worth 10, question 9 is worth 8, question 10 is worth 8. Can you write as fast as I can talk?
No, I missed the first 4.
Sonia got it, so you got to talk to her. So I got this. So S goes to A, S, A, or B, S, D, or empty, I think might do it. See, I got figured out.
12 points for 6?
Writing a grammar is like writing a program. You got tools, not many, but you've got a problem and then you create the solution. Building a grammar is a creative process, like writing a program. You write a program, you got tools. If statements, while statements, storage, for loops. I don't include for loops because I said while statements. Fors and whiles are same thing. Brandon?
So problem 3 is just the regular grammar form of
Regular grammar form with some string that I give you.
because 8's going to be the content.
I'll probably give you a regular expression. Maybe I'll give you a regular expression. If I give you a regular expression. Yeah, I gave you a regular expression. So a regular expression, you know the star and the bar and the parentheses are meta symbols. Just like the regular expression I gave you for floating point numbers, the question mark was a meta symbol, the parentheses meta symbols. Some of the pluses were meta symbols. You know what I mean by a meta symbol? Meta is a universal concept, not a concept just in computing. Meta is the technique of describing something else. And so they talk about meta languages, which are languages that describe other languages. It's a general universal concept, meta. Questions?
You're talking about question 7 as a regular expression, and you make context-free grammar out of that?
No. I mean, you could.
No, I mean,
If I give you a regular expression, you can build a context-free grammar. Because the context-free grammar is more powerful than a regular grammar. And so any regular expression can create a context-free grammar. It can also create a regular grammar. A regular grammar is more restrictive, less powerful than a context-free grammar.
okay, I see. So the regular, so then, where were we gonna get a regular expression?
Number 3.
Question 3 is build a regular grammar. Ron?
Your example you put up there for number 7, context-free grammar is incomplete. That only builds an even number of terminals, not an odd number. It's incomplete. You need or A or B.
For this one? Or this one?
That right there.
Yeah, that only builds
For
all
the end, you
palindromes.
need or A, or B, or F. Otherwise, you're only going to have an even number.
And you didn't list odd palindromes as samples that should be accepted.
Yeah, I can't get odd palindromes. I can get them mixed up, but I can't get odd number of characters. And so, yeah, I need an A or a B. Now I think it's better. Any other questions? Elizabeth? You're what? You're good?
Emily.
Her name's Emily.
Emily. Elizabeth Emily. I'm sorry. Jasmine?
Sonia.
I know. I did that on purpose.
For number 8, you're saying make it LL1. Right, what exactly?
It's a left factoring or left recursion question.
Like on the quiz, right? Number 8 on quiz thing. Yeah.
Emily? Randy?
Yeah.
Tyler? I was getting there. I was thinking of Travis and different things. Keith. So, I have a terrible day with first names. I have a terrible time with names. Worse with last names than first names. I'm making no attempt at last names. I'm picking off a few of you. Kevin?
Okay, I got off pace with the weights for the questions.
Sonia's got it.
So what are the last 5?
The last 5,
It's 12.
so 10 is 8, 9 is 8, 8 is 8, 7 is 8, 6 is 8, and number 5 is 12.
Okay, so the last 5 are all 8.
Except for number 5.
Number 5 is 12, 6 is 8,
Number 8 is 10.
And
So-
then
8 is 10.
Try to twirl a pencil. Questions?
Is there any extra credit?
No. Question?
Where's a good place that you can get good practice problems?
I'm sorry?
Where's a good resource where I can find?
Find practice problems?
Yeah, with writing.
There is in the public directory a subdirectory called homework. And there's 2 files in there, one called practice problems, practice grammars, I think. And then there's another file called practice grammar solutions. So you can take a look at those, and there's like 10 grammars that you can play with. Brandon?
Would you prefer talking about a last name if their last name's more unique than their first name?
I'm sorry?
Would you prefer to copy by the last name if their last name's more unique than their first name?
I still.
Would you prefer to call someone by their last name if their last name is more unique than their first name?
No, I think, I expect you all to call me Dr. Egger. I paid the price. I went to school for a gazillion years, and I earned a PhD. That warrants a Dr. Egger. Maybe if you'd like me to call you by your last name, I will call you Mr. whatever. But I like to feel warm enough or friendly enough to where we're in class. Learning should be a pleasant experience. And so I want to have fun. And I do have fun in here in general. Unless I'm trying to explain the difference between lexical analyzer and parser.
Or if there's an epsilon.
I'm only kidding. He wasn't listening. Maybe he was listening. Anyway, so I think I should call you by your first name. But if you'd like me not to, I'll respect that. And so I think I would like to call you by your first name. And everybody's got an acceptable or I mean, it's all acceptable, don't get me wrong, but first names that are not so hard to pronounce that I won't ultimately get them. I might struggle for a while, but I'll get them, and that's on me, not on you by any means. Very good.
Can you post a practice exam?
No,
Thank you.
Brendan?
You pronounce it Dr. Egan or Dr. Egan?
So I often will introduce myself as Egan, because if I don't, nobody can spell it. And so if I say Egan, then they start out Hagan or Agan. It's so many, they can't spell it. I often will say Egan like fried egg. You know, you don't order a fried egg. And it's pronounced like fried egg.
Dr. Eggman. So
Dr. Egan.
What?
Have you ever played Sonic the Hedgehog?
No.
I'm sorry.
Have you ever played the game Sonic the Hedgehog?
No.
There's like the villain in the game is Dr. Eggman.
Oh, yeah. Well, of course, you can imagine, in high school, I was called everything. Igor, and just, Egan in the for what it's worth category.
So it's Egan.
If you look at mountain peaks, and so then there might be cloud cover, so you can't see this stuff. Egan means mountain peaks rising above the clouds. I kind of like that.
So-
It is Scandinavian, primarily Norwegian. My father and my father was full Norwegian. My grandfather immigrated through Ellis Island in the 30s. And he and my grandmother on my father's side came from Norway. They were full-blooded Norwegian.
So it's Egan.
Egan. Yep, Egan. Just like fried egg. Egan.
Plead the rest.
Questions?
So just making sure, if we do the quizzes and we do the homework on the website,